Hi, I am architect Archana Agarwal. This video is on solid waste management and it is based on GRIHA version 2019. Waste is an unwanted or unusable material as commonly perceived. Any substance which is discarded after primary use or is worthless, defective, and of no use is generally regarded as waste. What constitutes waste depends on the eye of the beholder. One person's waste can be a resource for another person. There are different definitions used by different agencies. As per United Nations Environment Programme, wastes are substances or objects which are disposed of or are intended to be disposed of or are required to be disposed of by the provisions of the national law. As per United Nations Statistics Division, wastes are materials that are not prime products, for which the generator has no further use in terms of his or her own purposes of production, transformation, or consumption, and which he or she wants to dispose. Wastes may be generated during the extraction of raw materials, the processing of raw materials into intermediate and final products, the consumption of final products, and other human activities. Residuals recycled or reused at the place of generation are excluded. As per European Union, waste is an object the holder discards, intends to discard, or is required to discard. The waste can be in solid, liquid, or gaseous form. Solid waste is categorized into 4 types: municipal waste, hazardous waste, biomedical waste, and spatial hazardous waste. Municipal solid waste includes household waste, commercial waste, and demolition waste. Although the waste may originate from a number of sources that has nothing to do with the municipality, the traditional role of municipalities in collecting and managing these kinds of wastes have produced this particular term, municipal waste. Household waste, commonly known as trash or garbage, is a waste type consisting of everyday items that are discarded by the public. It also contains food waste. The segregation of organic and inorganic waste, the dry and the wet waste at the source itself has been enforced in many countries around the world. It has also been initiated in India. Commercial waste consists of waste from premises used mainly for the purpose of trade or business, or for the purpose of sport, recreation, education, or entertainment, but excluding household, agricultural, or industrial waste. Demolition waste is debris from destruction of buildings, roads, bridges, or other structures. Debris varies in composition, but the major components are concrete, wood products, brick, clay tiles, and steel. There is a potential to recycle many elements from the demolition waste. Hazardous waste includes industrial waste. It is the waste produced by industrial activity which includes any material that is rendered useless during a manufacturing process or during mining operations. Types of industrial waste include dirt and gravel, masonry and concrete, scrap metal, oil, solvents, chemicals, scrap, even vegetable matter from restaurants. Industrial waste may be solid, semi-solid, or liquid in form. It may be hazardous or non-hazardous waste. Industrial waste may pollute the nearby soil or adjacent water bodies and can contaminate groundwater, lakes, streams, rivers, or coastal waters. Industrial waste is often mixed into municipal waste, making accurate assessments difficult. Most countries have enacted legislation to deal with the problem of industrial waste, but enforcement is always an issue. Biomedical waste or hospital waste is any kind of waste containing infectious or potentially infectious materials. Biomedical waste may be solid or liquid. Examples of infectious waste include discarded blood, sharps, unwanted microbiological cultures and stocks, identifiable body parts, other human or animal tissues, used bandages and dressings, discarded gloves, other medical supplies that may have been in contact with blood and body fluids, and laboratory wastes that exhibit similar characteristics. Waste sharps include potentially contaminated used needles, scalpels, lancets, and other devices capable of penetrating skin. Hazardous waste is waste that has substantial or potential threats to public health or the environment. Spatial hazardous waste includes radioactive waste, explosive waste, and electronic waste, that is e-waste. Electronic waste or e-waste describes discarded electrical or electronic devices. These include refrigerators, air conditioners, small household appliances, IT equipment including monitors, consumer electronics including televisions, lamps and luminaires, toys, tools, medical devices, monitoring and control instruments, automatic dispensers, etc. Electronic scrap components such as CPUs contain potentially harmful materials such as lead, cadmium, beryllium, or brominated flame retardants. Recycling and disposal of e-waste may involve significant risk to health of workers and their communities. Waste management includes the processes and actions required to manage waste from its inception to its final disposal. This includes the collection, transport, treatment, and disposal of waste, together with monitoring and regulation of the waste management process and waste-related laws, technologies, and economic mechanisms. The aim of waste management is to reduce the dangerous effects of such waste on the environment and human health. A big part of waste management deals with municipal solid waste, which is created by industrial, commercial, and household activity. Talking about Indian scenario, the cities in India have been expanding at an unmatched pace, and this is expected to continue over the coming decades. Rapid urbanization and the consequent enhancement in the lifestyle of people are causing a huge impact on the environment, especially on the microclimate of all the growing and evolving cities due to problems such as increased burden on urban landfills. Solid waste management has become a cause for concern for many urban local bodies in India. Urbanization, industrialization, and economic growth have resulted in increased municipal solid waste generation per person. This figure shows the solid waste generation in various states of India. From this data of 2017, it is observed that approximately 1,45,000 tons of solid waste is generated per day across India. And this shows the current treatment capacities. Only 12 to 14% of the municipal solid waste is formally treated in India, and the rest is directly sent to open dumping and landfilling sites. Absence of proper segregation at source, generation of large quantities of solid waste, and challenges faced in the collection of waste on a regular basis make effective solid waste management a major challenge in cities with high population densities. For better waste management, solid waste management rules have been put in place by the central government, and several urban local bodies are also trying to reinforce waste segregation through adoption of color coding. For instance, most urban local bodies designate green bins for biodegradable waste, blue bins for recyclable waste, and black bins for other types of waste such as e-waste or hazardous waste. This figure illustrates how the municipal solid waste generation, land requirement, and the population are expected to increase from 2001 to 2051 if we do not divert waste from landfill sites. Thus, we need to devise and find more decentralized ways of managing and handling waste in order to avoid an exponential growth in the space required for landfilling. Despite significant development in social, economic, and environmental areas, solid waste management systems in India have remained relatively unchanged. One of the reasons for inadequate infrastructure is the shortage of funds that have been granted to municipalities for solid waste management. Solid waste collection accounts for most of the expenditure in the whole process of managing waste. This is due to maintenance of trucks, fuel costs, salaries, etc. In the absence of funds, there is sometimes a shortage in the staff and collection trucks required for collecting, segregating, and disposing of solid waste. Another huge problem that leads to poor management of solid waste is the lack of proper implementation of policies that have been launched by the government. In the past decade, the government has launched many programs and policies directed towards solid waste management. However, even till date, the percentage of industries, households, and municipalities following these rules remains very small. The waste that does not get recycled or reused eventually reaches a landfill, where it is dumped with the rest of the inert and mixed waste. Urban India generates around 62 million tons of municipal solid waste each year. Of this, about 70% are collected. From this, around 20% are treated, and 50% of the waste are dumped in landfill sites. Each landfill site upsets the aesthetics of the area in addition to contaminating the environment around it, both directly and indirectly. Solid waste that is collected in landfills instantly becomes a part of the existing hydrological system. Rainfall percolates through the stored waste dumps and forms leachate, which is acidic in nature. This leachate moves down from these sites and flows into nearby water bodies, contaminating them. Leachate produced from landfill sites also percolates into the soil. The effect caused on the soil can only be observed with time and might not be evident immediately after waste is dumped in the landfill. Leachate from these dump sites is generally toxic in nature and results in the degradation of the soil, thereby reducing its fertility over time and also damaging vegetation in the vicinity of the dumping site. The air in the vicinity of a landfill site is highly toxic and malodorous. In the landfill, a significant amount of gases consisting of methane, carbon dioxide, nitrogen, oxygen, hydrogen, and other greenhouse gases are produced that cause an increase in the temperature and changes in the climatic conditions. Landfills are the principal source of anthropogenic methane emissions. These emissions not only cause air pollution but also contribute largely towards climate change and global warming. As landfilling increases, waste may need to be incinerated in order to make space available. This releases toxins contained within the waste into the atmosphere, contributing to air pollution as depicted in the picture. The landfilling site may alter the composition of vegetation in the surrounding ecosystem. Dumping waste in landfilling site affects the flora and fauna on both land and water. It can disturb the species composition of native vegetation and allow invasion of invasive and non-native species. This figure highlights how the increased usage of paper and packaging materials leads to deforestation. A huge quantum of paper and packaging waste gets mixed with other municipal solid waste and ends up reaching a landfill site. Another particular waste that hugely affects biodiversity is plastic. Plastic was initially developed as a resource that had all the necessary properties required in any packaging material, that is cheap manufacturing, durability, and weather resistance. However, due to a combination of these properties, it eventually took over all other packaging products. Due to its inert nature, it can survive in the atmosphere for centuries without degrading. Countries started dumping plastics in oceans as shown in this figure. This was due to the lack of infrastructure to support the large quantities of these waste materials generated on a daily basis. Also, low quality plastics end up in landfill sites, which get ingested by birds, cows, and other animals and result in their untimely death. Most of the marine wildlife, like seabirds, whales, fishes, and turtles, perceive plastic waste as their prey and die of starvation because of their stomachs getting filled with all types of plastic debris that they have accidentally ingested. They also suffer from lacerations, infections, reduced ability to swim, and internal injuries. Buildings are an immense source of waste generation during the construction and operation phases. This figure shows the waste generation from different sectors in India. The quantum of waste that is generated from a building depends on factors such as occupancy, operation schedule, geographical location, socio-economic status of the inhabitants, along with their habits. As can be seen in this figure, The per capita waste generation from a residential building is much higher than from commercial buildings, followed by institutional buildings. The primary reason behind the same is that they remain occupied for longer periods of time of the day in comparison to institutional and commercial buildings. Commercial buildings, on the other hand, generate a higher amount of packaging and plastic waste. Offices generate paper and plastic waste in large quantities, while healthcare facilities generate biomedical waste in addition to other waste materials. The three R's, reduce, reuse, and recycle, are the three essential components of environmentally responsible consumer behavior. Various strategies that could be adopted to minimize waste generation from different building typologies are suggested here. For healthcare facilities, the waste generation can be reduced by employing strategies such as 1. Installation of dispensing units in housekeeping rooms to ensure that staff restricts themselves to using only the required quantity of chemicals. 2. Engaging in use of physical rather than chemical cleaning methods such as steam disinfection instead of chemical disinfection. 3. Provision of biodegradable foodware or reusable foodware like steel in canteens at healthcare facilities. 4. Use of air dryers instead of paper towels in restrooms. 5th, using different colored liners allows the cleaning crew to easily keep track of what is recyclable and which container it should be placed in. 6. Installing reverse vending machines which do not dispense something on inserting money but take in plastic bottle and dole out some sort of goodies or incentives for the user. For buildings under hospitality category, the suggestive strategies are use of dispensers, small containers or dishes for sauces, sugar, butter and other condiments instead of individually wrapped packages to reduce packaging waste. Use of cloth mats and permanent posters instead of paper mats and paper napkins that need to be discarded after every meal. Provision of water bottles that can be refilled instead of plastic disposable water bottles. Issue of newspapers to guests only upon request to reduce the volume of discarded newspapers. Newspaper may be offered at centrally located spaces such as lobbies, restaurants and news stands. Installation of refillable dispensers for bath soap, shampoo, hair conditioner, etc. to eliminate leftover soap bars and plastic bottles of used toiletries. Donation of unwanted items that are still in working condition such as linen, blankets, old curtains, porcelain and glassware to charitable organizations or the sale of such items to staff for reuse. Provision of slippers only upon request. If the hotel's policy is to provide slippers in all guest rooms, then wrapping them in disposable plastic bags should be avoided. Provision of reusable laundry bags for guests instead of single-use plastic bags. Laundered clothes may be returned to reusable garment bags instead of single-use plastic bags. Using different colored liners allows the cleaning crew to easily keep track of what is recyclable and which container it should be placed in. Encouraging frequent ordering of relatively small quantities instead of large quantities at one time. Installing reverse vending machines which do not dispense something on inserting money but take in plastic bottle and dole out some sort of goodies or incentives for the user. Strategies for waste reduction at source suggested by GRIHA for office buildings are: printers may be equipped with access card control to ensure that only requested print jobs are executed in order to reduce accidental printing and resource wastage. Usage of refillable stationery such as pens, highlighters, correction tapes, and whiteboard markers should be promoted. Replacement of paper towel dispenser with modern cloth towel dispenser which disinfects the cloth after every usage. Refilling and recycling of empty cartridges. Use of biodegradable stationery such as pens made of corn starch. The choice of colored liners within bins may be impactful. Using different colored liners allows the cleaning crew to easily keep track of what is recyclable and which central collection container it should be placed in. For residential buildings, the strategies for waste reduction are education of residents through outreach programs that explain techniques, costs, benefits, and examples of source reduction that can include presentations, workshops, videos, etc. Reduction in the quantity of newspapers and junk advertisement material by switching over to digital media. Returning hangers to local dry cleaners in the building area for reuse. The buildings for retail can use strategies like reuse of fixtures, furniture, carpeting, and construction material obtained from the remodeling of stores. These materials can either be reused within the premises itself or sold to recyclers or donated to an NGO working with recycled materials. Using different colored liners to segregate the recyclable material. Stores can use shredded waste paper as packing material. Encouraging frequent ordering of relatively small quantities instead of large quantities at one time. Installing reverse vending machines. The strategies for waste reduction at source given by GRIHA for transit terminal are: rethinking of the labeling on waste bins. Instead of writing glass, plastic and aluminium, if it is written bottles and cans, it might provide greater clarity to users and reduce confusion. Attaching photographs of sample waste materials on dustbins will also provide better understanding to the users and avoid mixing of wastes. Some airline lounges already have locations where discarded newspapers and magazines may be used by other passengers. This form of reuse should be encouraged. The choice of colored liners within bins may be impactful. Using different colored liners allows the cleaning crew to keep track of what is recyclable and which central collection container should it be placed in. Food vendors at the airport can use biodegradable foodware instead of disposable plastic materials. Replacement of paper towel dispensers with modern cloth towel dispensers. installing reverse vending machines which do not dispense something on inserting money but take in plastic bottles and dole out some sort of goodies or incentives for the user. Beginning from the construction stage to the demolition stage, a building generates different types of wastes throughout its life cycle. These wastes are broadly classified into organic and inorganic wastes. The various methods of treating these wastes depend on the composition of the waste material. The chart here illustrates the strategies that could be adopted for treating the different types of wastes. The organic waste or wet waste is biodegradable in nature. This fraction of waste, once segregated from the inert fraction of solid waste, can be easily utilized as a resource with several applications. In a developing country like India, a large fraction of the total solid waste generated is organic in nature. According to National Building Code, about 40% of the total municipal solid waste is organic. Organic waste not only consists of food and kitchen waste, but also has a huge fraction of landscape waste. Organic waste does not contain any recyclable material and is of no value to rag pickers and recyclers. Thus, if it is not treated before disposing from site, it gets dumped into a landfill. Hence, this organic waste should be segregated and subsequently treated and converted into a resource at the earliest stage to derive maximum potential. Pit composting is one of the methods of converting organic waste into a resource. It refers to biological decomposition of organic waste by bacteria, fungi, worms, and other microorganisms in controlled aerobic conditions to produce compost. The compost produced from this process is a natural soil conditioner that is rich in nutrients and may be used to enhance the fertility of the soil and boost the growth of vegetation in the soil. The common composting techniques are vermicomposting and mechanical composting. Vermicomposting uses various worms to create a mixture of food waste, bedding materials, and vermicast. Vermicast is the end product after breakdown of organic matter by the worms. The vermi manure thus produced has fewer contaminants and therefore reduces toxic emissions into the atmosphere. It is enriched with nutrients and is a valuable fertilizer for soil. Cross-section of a typical 3-bin vermicomposter is shown here. The other type of composting is mechanical composting. A variety of mechanical systems and technologies are available in the market depending upon the quantum of waste generated, the amount of space available for treatment, time available for treatment, ease, as well as the cost of operation. Some mechanical composting technologies are listed here. Biomethanation involves the digestion of organic material by microorganisms under anaerobic conditions into biogas. Biogas is a combustible gas rich in methane and can be used for cooking or for generating electricity. In addition to biogas, the process generates compost that can be used as soil fertilizer. Biogas is a renewable source of energy that utilizes the organic waste that would otherwise have been sent to a landfill. Installing a biogas plant is also a cost-effective strategy. Some of the biodigesters available in the Indian market are TEAM, RT, and Municipal. This diagram shows the process flow of TERE's enhanced acidification and methanation technology. The Compact Biogas System by Appropriate Rural Technology Institute, commonly known as RT, uses starchy agro waste, non-edible seeds, or leftover food. The main objectives of this technology are to reduce fuel cost, replace fossil fuels in cooking, dispose of organic solid waste at the point of generation, produce clean fuel in the form of methane, reduce BOD and COD values of the waste, and reduce the cost of the organic solid waste disposal. Nisar Bruna Biogas Plant, built by Bhabha Atomic Research Center, can process biodegradable waste such as kitchen waste, grass, dry leaves, paper, and dung. It offers zero garbage and zero effluent and provides methane gas along with high quality manure. Next is the inorganic waste. Once the biodegradable fraction of solid waste has been segregated and treated, the inert fraction of waste has to be treated separately. The methods of handling inorganic solid waste involves all recyclable fractions to be extracted and separated in order to minimize the quantum of solid waste so that further treatment becomes easier. Once all resources have been derived from solid waste, the rest of it is converted into energy. The commonly known technologies for converting waste to energy are incineration, gasification, and pyrolysis. Combustion or incineration is the oldest and most common way of treating solid waste. It merely involves combustion of waste in large furnaces in order to produce heat that turns water into steam and that moves the turbine, thereby producing electricity. Gasification is done in a limited supply of oxygen. Steam or oxygen in the air reacts at high temperature with the available carbon in the waste material to produce gases such as carbon monoxide, hydrogen, and methane. The gasification process produces syngas that is used to turn turbine, which in turn generates electricity. Pyrolysis is also a thermal process similar to gasification. It works in the absence of oxygen and uses heat to break down organic materials. Materials such as coal, animal and human waste, food scraps, paper, cardboard, plastics, and rubber are suitable for pyrolysis processing. This process produces oil which can be used as synthetic biodiesel or refined to produce other useful products. Another common byproduct of pyrolysis is charcoal. The next category of waste is construction and demolition waste. Construction waste poses a great danger to the environment. For this reason, construction industries need to find suitable methods to manage construction and demolition materials that generate waste during construction activities. Using trash chutes to get waste out of the site is one good way of safe waste disposal. Construction and demolition materials consist of debris that is generated during construction, renovation, and demolition of buildings, roads, and bridges. Some of the heavy and bulky materials used in construction are concrete, wood, asphalt, metals, bricks, glass, rocks. Benefits of reducing disposal of construction and demolition waste materials are many. It will create employment and increase in economic activities in recycling industries. This will also increase the business opportunities within the local communities in areas where deconstruction and selective demolition are used. There will be overall reduction in building project expenses through avoided purchase costs and donation of recovered materials to qualified charities which offer a tax benefit. Transportation costs also come down with on-site material reuse. Fewer disposal facilities which reduce associated environmental issues. Conservation of landfill spaces. The environmental impact associated with the extraction and consumption of virgin resources and the production of new materials is offset. The waste management practices for C&D wastes are reduce, divert and reuse, and recycle. With source reduction, one can reduce the life cycle of material use, energy use, and waste generation. Source reduction prevents waste from being generated in the first place. Some examples of this include preserving existing buildings rather than constructing new ones, optimizing the size of new buildings, designing new buildings for adaptability to prolong their life, use of construction methods that allow disassembly and facilitate reuse of materials, and employing alternative framing techniques. Reducing construction and demolition debris also conserves landfill spaces, reduces the environmental impact of producing new materials, and can cut down the overall building project expenses through avoided purchase. Raw construction and demolition debris can be diverted and used as a resource. Some materials that can be diverted include landscape and land clearing debris, asphalt pavements, gravel and aggregate products, concrete, masonry scrap and rubble, clean wood, plastics, insulation materials. Recovering used but valuable construction and demolition materials for further use is an effective way to save money and conserve natural resources. Deconstruction can be used at a number of levels to salvage usable materials and significantly cut the waste. A number of building components and construction debris can be recycled. Concrete and rubble are often recycled into aggregate and concrete products. Wood can be recycled into engineered wood products like furniture. Metals like steel, copper, and brass are also valuable resources to recycle. Inert waste is waste which is neither chemically nor biologically reactive and will not decompose or only very slowly decompose. Examples of this are sand and concrete. This has particular relevance to landfills as inert waste typically requires lower disposal fees than biodegradable waste or hazardous waste. The steps of solid waste management are waste collection, segregation, transportation, processing, and disposal. Now let me deliberate on the challenges faced in solid waste management in buildings. Segregation of waste is the primary step in the process of waste management and is extremely crucial. This could help in either smoothing the process of waste management or making the process cumbersome. The biggest challenge India faces in terms of solid waste management is the lack of awareness amongst building occupants and visitors about the impact caused by unsegregated waste. This picture depicts the scattering of mixed waste on a project site. Due to the massive chunk of unsegregated waste, the urban local bodies have to spend a lot of money to transport and sort this mixed waste before it is dumped into landfill sites, of course after withdrawing possible recyclables. Creating awareness amongst the building occupants can be done by stressing on the fact that putting different waste materials in separate bins not only reduces the overall cost of managing solid waste, but also ensures that maximum resources are derived from the waste stream, which otherwise would have been disposed of in a landfill. Another challenge faced is absence of infrastructure at building or site level to ensure proper segregation. Most of the buildings that exist or are under development have a provision of limited space for waste storage on site, as it is mostly considered a waste of space and generally given less importance. Due to the unavailability of dedicated multicolored bins and storage spaces for segregated waste, it becomes very difficult to separate different streams of waste. The absence of proper infrastructure that can facilitate and support the segregation of different streams of waste paves the way for mixing of waste and significantly reducing its reusability as depicted in this picture. Collection of waste along with its safe storage and transportation are vital elements of any solid waste management system and can prove to be a major challenge in developing countries. Waste collection is the responsibility of the municipal corporations in India, and bins are normally provided for wet and dry waste. As of 2017, out of the total municipal solid waste generated in India, 91% was collected, of which only 23% was treated and remaining was landfilled. Municipalities across India are in the process of improving the collection mechanism. This figure depicts a municipality garbage truck collecting wet waste at community level. A big challenge that urban local bodies face is that only a small percentage of the population across the country actually segregates waste at source. Due to this, when municipalities collect the waste from different locations, the segregated waste streams end up getting mixed with all the other waste that is collected, as shown in this figure. This mixed waste, which has been collected by the municipalities, is sorted on a daily basis at all collection centers. However, the purpose of segregation at source is defeated in this case. Dedicated recyclers for different streams of waste have started increasing over the years, yet the number has not reached a point where it becomes easy for small-scale projects to approach these recyclers. This results in most of the waste from small-scale projects to be handled by their respective urban local bodies. Hence, the possibility of recovering the maximum potential from these waste streams is still not utilized by these projects till date. The figure depicts rag pickers segregating and collecting recyclables from a landfill site. There is an urgent need to move to more sustainable waste management, which would require new management systems and waste management facilities to be incorporated across the country. Several waste management rules and regulations have been drafted and released. However, there has been a slack in their on-ground implementation. There is a need to create a dedicated group of officers and skilled staff at the local level for a robust implementation. Adequate training, capacity building and hands-on experiments would enable them to identify bottlenecks and take appropriate action. Also, sustainable, effective waste management could only be achieved through proper implementation of the rules, industry incentives, and public awareness. With the aim to address the need for waste minimization along with proper segregation, collection, and management, certain sustainable development goals have been rolled out by the United Nations to enhance resource efficiency. SDG 12 refers to responsible consumption and production. Goal number 12.3 intends to reduce the per capita global food waste to 50% at the consumer and retail levels and diminish the food losses along production and supply chains, including post-harvest losses. This could be achieved by bringing in behavioral change in the consumers as well as retail owners to reduce the impact on the environment. Goal number 12.4 intends to achieve the environmentally sound management of chemicals and wastes throughout their life cycle in accordance with international frameworks and significantly reduce their release to air, soil, and water in order to minimize adverse effects on human health and on the environment by 2020. The waste management rules have been developed in India to cater to this particular goal of the SDGs and help India address its problem of waste disposal and management. Goal 12.5 aims to substantially reduce the generation of waste through prevention, reduction, recycling, and reuse. To cater to this particular clause, Government of India has come up with a resource efficiency policy, and the hierarchy of the waste management process has been redefined to cater to 6 R's: reduce, reuse, recycle, refurbish, redesign, and remanufacture. Over the last decade, the Government of India has been proactively emphasizing on the importance of appropriate solid waste management across the country. The government has been launching new programs and policies in order to promote efficient waste management and push for better sanitation and cleanliness around India. Some of the programs that have been launched by the Government of India are Swachh Bharat Abhiyan, Swachh Sarvekshan Survey, and Swachhata app. Resource efficiency policy launched by Government of India demands for 100% recycling and reuse rate of PET plastic by 2025 and 75% recycling and reuse rate of other plastic packaging materials by 2030. It also suggested a ban on disposal of recyclable waste to landfills by 2022. The recyclable waste includes plastics, metals, glass, paper, cardboard, and biodegradable waste. The action plan also called for a 50% recycling rate for construction and demolition waste by 2025 and 75% by 2030. Solid waste management rules were initially launched in 2000 and subsequently were amended and notified in 2016, providing a regulatory framework for the management of solid waste generated across the country. The rules include construction and demolition waste management, biomedical waste management, battery waste management, and plastic waste management. Also, there are rules for hazardous waste management and e-waste management. In order to make waste management achievable at the ground level, several states have adopted strategies to penalize the waste management process. One such example is Brihat Bengaluru Mahanagarpalika, which has imposed penalties ranging from 2,500 rupees to 2 lakh rupees and applicable to event holders who are flouting solid waste management rules and plastic waste management rules. Another example is Corporation of the City of Panaji, Goa, which has initiated the process of giving financial incentives for recycling. Government of Haryana gives incentive in the form of additional FAR of 3% for all building users who install solid waste management plant for treatment of total generated waste. These are some case studies of projects who have targeted net zero waste. Dalmia Vidya Mandir, Rajgangapur, Odisha was the pioneer project in GRIHA, and it has been planned exceptionally well. Located in the township developed by Dalmia Group, this project has devised measures to handle all the waste that is generated within the campus. All the paper waste that is generated within the school premises is being used for paper mache in the school's art room, while all other waste is being sent to the incinerator located within the campus, which generates energy to power the cement generation plant. In Pune, the Zero Waste project at Kathraj was undertaken in association with NGO. The corporation banned open dumping in June 2010, and all disposals are done using scientific processing only. There are 5 decentralized waste processing plants across the city. PMC has activated a new mobile SMS alert system for timely and effective complaint redressal regarding garbage containers. This type of model is a first in India that received ISO certification for solid waste collection and transportation. After successful implementation of this model, it was decided to replicate this model in 20 selected electoral wards in a phased manner. Chappan Dukan at Indore is an organic waste collection center that is located inside a lane that is lined with small eateries. The market produces on an average 1.5 tons of food waste daily. This waste is composted and sent to other center for further processing. Indore has also set up a facility to process waste from vegetables, fruits and flour. This waste is converted into biogas, and the gas produced is used to run city buses and sold as cooking fuel to hotels and Indian Institute of Management at a subsidized rate. For more information on various techniques for solid waste management and on how to do biogas calculation, view my video on YouTube, Checklist for Architectural Design and Thesis Drawings. Subscribe to my YouTube channel and view many such educational videos.